Hello and welcome to Amazon IoT Lambda Fun. So what we're going to do is we're going to go ahead and set up a Amazon IoT device client and backend and connect them up. So if we go here and go to the AWS IoT service, then we can go ahead and do the little quick start here to configure a device. So what we're going to do is create a SDK certificate and thing for OS 10 and Python. And we'll give our thing a name called unit thing. And then it's going to give us a zip file that has the certificate and private key and Python SDK, and I'll register a thing for us and a policy for that thing in the registry. So I'll go ahead and download that zip file here and then move on. So what does the zip file contain? That's over here. I have it. So this is the Connect device package. It comes with the AWS IoT Python SDK, and it comes with some sample programs here. And so we're going to run the thing shadow echo sample program. And what this will do is it will connect the shadow client and listen for updates, changes to the device shadow for that thing. So what I'm going to do real quick is take a certificate that I already have set up for it and attach it to the thing and attach it to the policy for our thing which just got created. And then we should be able to go ahead and connect. So to run the demo, I'm going to run thing shadow echo with Amazon's root CA, and then the certificate for our endpoint, and then the private key for our thing so that it can do mutual TLS authentication. And then we're going to give it the endpoint address for our gateway. And so our endpoint address is here. You can find it in settings. It'll be different for every account. And that's what you connect to for the device. So we'll go ahead and connect here. And now it is subscribed for the Delta topic for device shadow unit thing. And so this means when changes in the device shadow happen for unit thing, they'll tell us the delta between what is desired and what the current thing's shadow is. And so we can go ahead and look in the registry here for our thing. So here's our unit thing. And we can see that it has no device shadow right now, no state. So what we're going to do is we're going to declare a desired state, and then the device shadow should get the device client should get a message telling it that there's a delta between the desired state and its current state. So we're going to say our desired state is now do stuff. We want to get this done as soon as possible. Okay. So there's just some random, arbitrary JSON payload here that we can put into the desired state. We'll go ahead and click save. And now if we go over to our client here, we shall see that we got a delta message. And so this is the difference between what the state was, which was nothing, and now the new desired state, which was this JSON payload. And now it applied the delta, which doesn't actually do anything right now, but it could. And then it'll update the reported state. So now if we go over here, we'll see that the desired state also matches the reported state from the client. So this is really useful for kind of messaging devices that may be offline, because your devices might not be always connected to the internet or turned on or connected to the gateway. So the shadow state is a great way for sending asynchronous messages and managing device state, keeping track of what's been actually applied, as well as there may be multiple shadow updates, but the device will always apply only the latest shadow state. So that can be really useful, because typically if you're using MQTT, the messages can appear kind of out of order, but the device shadow will always use the latest state, so you don't have to worry so much about message ordering with device shadows. Okay, so that's a simple little example using the pre-made client there. Let's look up something a little more fancy and cool. So what we're going to do is we're going to go over to AWS Lambda here. And we're going to create a function. So in Lambda, you can write code that just kind of executes. We're going to create a new function. It just executes. It doesn't require any running server. It just kind of lives in the cloud. We're going to make one from scratch here. We'll hook up the trigger in a minute. And what we'll do is we'll create a little function called poke, and we'll pick the cool runtime, which is Python 3.6. We'll make, right now it just doesn't do anything, just returns hello. Okay. And then what we're going to have this function do is it's going to receive a message from an IoT client, and it's going to pass that message on via SMS to my phone. So how is it going to do that? Well, I have a simple notification service endpoint set up here, which goes via SMS to my phone. This is the topic ARN, Amazon resource number name, for the SNS topic, the simple notification service topic, and there's an existing IAM role here called notify Lambda, and what this gives permission to publish to SNS to this ARN. So basically, this allows whoever has this policy to send me a text message is effectively what this says. And then this policy also allows it to put logs into CloudWatch. So this is useful also for Lambda for recording logs of what your Lambda is doing in case you have any output or errors that you want to go back and look at. So this is my policy for the Lambda. So I'm going to go ahead and attach that. Notify Lambda, role, and create our Lambda function. So this is just some Python code that'll execute. I don't have to run it on a server. It just kind of magically runs in the cloud whenever I invoke it. Cool. So how do we trigger that using IoT? We go over here and we can create a rule for our thing. And so we'll call it unit rule. And what our rule will say is when we get a message on a topic, so we'll call our topic unit topic. We'll say any single word subtopic of unit topic. So basically unit topic / foo or whatever. We'll pass these attributes to the Lambda. So what we're going to select is everything that was sent by the client. And also it's helpful to grab principal function as client ID. And so this is a good way to keep track of which thing sent the message. Principal will be the certificates, public, the certificate that sent it, essentially. And then what we'll do is we'll add action when we receive a message. There's lots of cool actions you can do, like put stuff in S3 or in a database table or whatever automatically, or the most powerful is to invoke a Lambda passing the message data to it. I'm going to configure that action, and we're going to say when we get a matching message, we'll invoke poke, add the action here, create the rule, and there we go. So now we have a rule in IWT that says when we get a message on this topic, send this to our Lambda over here. So our Lambda right now is pretty boring. It doesn't do anything useful. We can go ahead and just invoke it real quick just to see what happens. Basically, if you want to see the output, you can go over to monitoring here and click view logs in CloudWatch. And this is very useful for kind of debugging, seeing what your Lambda is doing, seeing if you have any errors, stuff like that. Really helpful. So sometimes the logs are a little lagging behind, but this is where you would see errors appear and stuff like that. Okay, so let's go ahead and edit our Lambda. So we'll go over to our nice little editor here, Sublime Text, with our Lambda editor plugin. Very nice plugin that lets you go easily edit Lambda functions inside Sublime. We'll go ahead and select poke here, and we'll download the function, and we can go ahead and edit it. So I have a little quick Lambda written here already. It looks like this. So Odo3 is a library for interacting with AWS APIs. It comes for free with any Lambdas already, so we have access to it. And we use that to basically say, all right, we want to talk to SNS, the simple notification service, and we want to talk to the topic, and this is the ARN for the notify Misha endpoint, which is over here, which sends me a SMS, which our Lambda has permission to do. So our Lambda, because it's running with the notified Lambda IAM role, it allows us to publish messages on this topic. So we're going to publish a message that says, and let's throw in the client ID here. So event record, this event contains the attributes that we selected in the rule. And so we got client ID, as you'll recall. And we'll say the client ID poked us, and then we'll pass in the poke field from the event record. So just to remind you, client ID here comes from the rule here. So we're selecting principal as client ID, and then we're selecting everything else that was sent as part of the message on this topic. And so we'll be expecting a field called poke to live on the event record there. Okay, so we'll go ahead and save that, and it'll automatically save and upload as the new source for our Lambda, thanks to the cool Sublime Text plugin. And then I made a simple little AWS IoT client here in Python. So this will connect with the MQTT client, which is a simple message queue telemetry transport client, very lightweight message passing library and protocol ISO standard. So we're going to connect as the thing named unit thing, and we're going to connect to our endpoint using our private key and using the certificate for our endpoint here. Go ahead and connect. And then we're going to go ahead and publish on the topic unit topic / poke. This can be anything because we configured our rule to match any word here, but I'm going to call it poke or anything else we want. I'm going to say poke hello. So this field here will match our Lambdas. This is what's being passed in the event record to our Lambda. So that's matching this here. So we're going to say hello, and then we're going to send it with QoS1, which essentially means try to deliver one message to our device. If it's QoS0, then that means like don't really try that hard. And then we'll let it drain the queue because it's kind of an asynchronous message queue here before we quit. Okay, so let's go ahead and try this out. And what we should expect to see is if we run this client program here, it should invoke our Lambda with this event record, and then our Lambda should go ahead and publish a message on our SNS topic with this text here, and then that should get SMS'd over to me. So I'm going to go ahead and check my text messages here, and we'll go ahead and run our client and see what happens. So go ahead and run it. All right, so now it should have invoked our Lambda, and there's our text message right here. Bam. So you can see that here's the client ID of the sender. So this message here matches the certificate that we connected with, which you can see here. So this is 838EBAC, blah, blah, blah. That's the certificate. So this is the client ID, the principal. Say they said hello. And so I can go ahead and change it to be, poke, yo, what up, save, rerun it, and then we should get a new text message with the new value. And there it is. Yo, what up? Pretty cool, right? So that's all without running any server anywhere. We can basically do almost anything with our Lambda code here. And we can see invocations here. And we can go view the logs if we want. There's nothing interesting in them, but they're useful, especially if nothing happens and you want to see if there's an error. This is very useful to go kind of look at the logs. And we don't have, again, no infrastructure. This will work just as well with one device as it will with 10 million devices. AWS Lambda will automatically kind of scale up and down to handle however many requests we want to throw at it. It's essentially free for a lot of invocations per month, so you don't really have to worry about it. And it's all nicely secured with mutual TLS authentication, very flexible rules and policies and security, IAM roles and policies and things. And it's a pretty sweet setup. And you can use Python SDK, Java, JavaScript, and there's even a nice embedded C API that I recommend, although they don't really talk about that much anymore for some reason. But it has a very nice embedded C API as well if you want to use that. So that's a nice little introduction to AWS IoT. I hope that was helpful and you enjoyed it. Thank you.